Go. Test, test. All right. Welcome to Ingesting Events at Massive Scale with Azure Event Hubs. My name is Nicolas Martin. I'm a principal consultant at Cardinal Solutions Group. And this presentation really came out of a project that I was involved in about a year ago. It was an Internet of Things application where we had devices that were communicating some pieces of data over the internet, and it was at very high volume, high throughput messaging. At the time when we built that application, Event Hubs didn't exist. It wasn't a thing. But before we released it, Event Hubs went out in preview, and we started looking at it, and we realized that this is a really great technology for the kind of applications we built. And it really would have made a lot of the coding that we had to do greatly simplified. So, I took the time to kind of research it and play with it. Got pretty excited about the technology. I think it's really cool. So I thought I would share it with you guys here. So before I get into it in detail, I just have some questions to kind of gauge the audience. How many of you have built applications, transaction processing applications, where maybe throughput was a real challenge? You had just massive amounts of events. You couldn't really keep up with it. I know it's late in the afternoon. Just raise your hands up high if you've built those kinds of systems. All right, a few hands. What about applications where you receive an event and maybe you have a whole lot of complex logic you need to do with it? A ton of different operations you need to perform on that event. Maybe that made the code pretty messy. Maybe it led to kind of a complex architectural design where you had queues, feeding other queues, feeding other queues, feeding other queues, and so forth. Oh, hands up high if you built something like that. Okay, quite a few. And then third, and this one might apply to almost everybody in this room, you had a system that you instrumented with a lot of diagnostics, logging, maybe some telemetry to understand how the users are using the application. And maybe that data, you just kind of put it away. It's there for debugging purposes, but there's value in that data, but you're not using it for anything. Show of hands if you built something like that. Okay, a lot of people. So if you raised your hands, you're in the right room. Event Hubs gives you a really good way to address some of those kinds of system needs. So today I'm going to talk about what Event Hubs is. Then we'll talk about how it works. There's a quick demo. It's not a live demo. It's not live coding. It won't be. I won't run it or anything. But I'll just kind of show some of the code so you can know what it looks like. And then there's going to be. I'll talk about a use case. I'll reveal some tips and tricks, and we'll wrap up with some complementary services within Azure. So Event Hubs exists within the Service Bus family of offerings in Azure, along with queues and topics. If you zero in on Event Hubs, it's really comprised of three main parts. You have the publisher, that's the author of the events, and then the consumer, which are actually consumer groups, that read events off the Event Hub, and then partitions. And partitions are really the critical piece to Event Hubs. So we're going to be spending a lot of time talking about partitions and what that does for us. But first, kind of, what everybody does, they show on an Azure presentation is they show how easy it is to provision this through the portal. So you start by creating a Service Bus namespace. The important bit here is that you need to select messaging, the messaging type of namespace. Don't get confused by the word hub in notification hubs. Notification hubs do not support Event Hubs. Then you create the Event Hub, associating it to that namespace you created. And there are two pieces of configuration you need to do to get up and running with your Event Hub. The partition count, how many partitions you want to provision, and the message retention. It's very important to note, and they kind of, I wish it didn't work this way, but when you set that partition count at the beginning, even before you built the system and know how it's going to perform, you're locked into that partition count. So I'll talk a little bit more about how to decide what the partition count should be later. Retention days is simply how long the data is going to exist in the Event Hub after it's been written. So to understand what Event Hubs gives you in the context of Service Bus, I think it's helpful to understand what it doesn't give you. So queues and topics in Service Bus give you what's called dead lettering or a poison queue. If an event continually fails processing, it'll go into a dead letter queue and kind of gets it out of the way so it doesn't hold up processing. You don't have that capability in Event Hubs. You have to deal with it yourself. There's no transaction support. So if you want to wrap a transaction around writing or reading an event from Event Hub, not supported. There's no processing assurance. A publisher will send an event into Event Hub. It'll know that it got there, but it'll never know whether or not it got picked up or got processed by any consumer. You also have no message sequencing like you do with topics. Now, there's a little bit of a caveat there. If you use a partition key, then all events that use the same partition key will be in sequence, but they won't be in sequence against the entire Event Hub. And you don't even get to control message deletion. So Event Hubs will just decide to roll off messages based on your retention period. With queues and topics, the support, because they do support these capabilities, they give you really fine-grained control over individual messages. But that introduces a lot of locking. And this creates what's called a competing consumer model, where you have multiple consumers trying to work with the same physical underlying resource. And for anyone who's familiar with that Monty Python skit, Mr. Ellison here, he eats that wafer-thin mint, and it takes him beyond his breaking point, right? Topics and queues have a breaking point. There is a point at which they simply cannot handle more messages due to the amount of locking and coordination that has to happen with them. Event Hub solves that for us. So what do we get with Event Hubs? Event stream processing, which is kind of a new paradigm of how to approach data and workloads. They're characterized by being very decoupled. So you have publishers that author events and put them into the Event Hub, and those publishers know nothing. They have no concern about what the downstream processors are, what they look like or anything. The consumers themselves don't even know or care about any other consumers. They get to work against the Event Hub completely independently. And in fact, the stream itself is not even concerned about how many publishers there are or who the consumers are. It's just everything is highly, highly decoupled. Stream partitioning is the facility in Event Hubs that gives you high concurrency, high parallelism as you process messages. You get a message retention period, so your events just eventually drop off. But since you don't actually ever delete messages, they just kind of fall off. As long as you're within your retention period, you get to replay the event stream as many times as you need to. There are often use cases where you want to reprocess events over and over again, maybe with the same consumer or with different consumers. As opposed to the competing consumer model, these capabilities give you what's called the partitioned consumer model. So your consumers work independently against their own partition of the event stream in the Event Hub. With the partitioned consumer model, you end up with super fast throughput. What the heck do I mean by super fast throughput? Let's look at some numbers. First, it's important to understand, this is a cloud service. Cloud services are always metered. You pay for usage. In Event Hubs, you're paying for throughput units. You get 1 megabyte of ingress, that's data coming into the Event Hub, so your writes to the Event Hub, and 2 megabytes of egress per second. And 1 throughput unit is approximately $22 a month. You get a kind of a soft max of 20 throughput units. If anyone here, for those of you familiar with Azure, you know that there are a lot of those kind of soft limits in Azure where you have to get in touch with Azure support and they'll extend it to fit your needs. So in terms of what Event Hubs is capable of, if you go to the Azure site and go to the Event Hubs page, in big letters you see this claim: stream millions of events per second into multiple applications. Right? That's huge. The Internet of Things application that I built didn't even come remotely close to that kind of volume or throughput. It was still pretty substantial, but millions of events per second is, probably none of us in this room have any kind of workload close to that. So what's it take to get an Event Hub to actually satisfy that kind of throughput? Well, let's look at a sample message. I kind of made up this message, kind of imagining if I was building like a smart grid kind of a system. And this is about a typical sized message you might want to run through an Event Hub. It's got some kind of identifier information there with that meter number, some reading, telemetry information, some timestamps for record keeping, and then some status codes. So pretty typical kind of message you would want to process. This is in JSON format, so it's nice and pretty human readable. And if you add up all the characters, this is about 200 bytes. Typical message, 200 bytes. So to get 1 million of those through Event Hubs, at a 200 byte message, we'd get 5,000 messages per second per throughput unit. Over 1 million messages, that would mean 200 throughput units. So we have a disconnect there, right? Kind of doesn't seem to fit their claim. So you have a choice now. You can either contact Azure support and say, hey, I need 200 throughput units, or we can revisit the message and see if we can shrink it down. We needed 10 times more throughput units than we would want to allocate. So can we shrink this message to 1/10? And the answer is yes. If you add up all the individual bytes for that data and you just send it in binary, it's 20 bytes. So you can get 1 million messages through there. Now there's a bug in my slide. The meter number has too many digits. I was mashing the keypad a little too aggressively. That was supposed to be an int. It ended up being a long, but whatever. So what's the architecture of an Event Hub system? Well, you start with publishers, and they author events. Those events get written into the Event Hub. On the other side of the Event Hub, you have consumers that start working their way through the Event Hub, through the stream of data. Looks pretty typical, right? I mean, that's your typical messaging queue kind of system. But there are some nuances with Event Hubs. We'll start by talking about the publishers. You have two main concerns as a publisher. First is actually streaming the data into the Event Hub. And you have 3 things to decide to do that. One, do you want to send your events in batch or individually? For a publisher that's creating events very, very rapidly, you definitely want to send them in batch. You get much better throughput that way. Either way, though, you're limited to a 256K message, regardless of how many events are in that message. And then you have to decide the protocol to use. AMQP 1.0 is it's a messaging protocol. That's really good, again, in those situations where you have very high velocity of events going through. But there is a cost associated with AMQP. That's actually metered as a Azure Service Bus brokered connection. That's about 3 cents per month for each concurrent connection, unless you have like tons of connections, and then the price drops significantly. Alternatively, you can just send the message through good old-fashioned HTTP. If you're sending events infrequently, or you have like millions of publishers and you don't want to incur that connection cost, HTTP is a good way to go. With HTTP, the performance difference results from the fact that you need to renegotiate the SSL connection and all that with every message. AMQP, once it's an established connection, you don't have to go through that overhead again. Then you got to decide a partitioning strategy. If you do nothing and you just write events to the Event Hub, it effectively is round robin. You send an event, the Event Hub will do some kind of a hash, or based on timestamp, something, I don't know. It'll just throw it in a random partition. If you need all the events that are related to be processed by the same consumer, you would use a partition key. So that enforces every message with the same partition key goes to the same consumer. And then you have the ability to send messages, events, directly to a particular partition. That one probably that won't get used very much, but if you know for sure this event belongs in partition number 7, you can do that. I want to caution you, if you do use anything other than round robin, that your scaling may suffer. If, for example, you use partition keys and 90% of all your events come from the same, let's say, customer ID. Let's say customer ID is our partition key. 90% of our events are from that customer. We're going to, be completely out of whack with our partitions. The poor consumer that has to handle partition 2 here won't be able to keep up, and then the other consumers will just be sitting on their hands waiting. Partitions are actually just a big contiguous block of blob storage. It's Azure Blob Storage. It's just an ongoing stream of data. And then as you write events to the Event Hub, it just starts filling up, and then the consumers come in behind and start processing. When you create the Event Hub, you choose between 8 and 32 partitions. That's another one of those soft limits. If you need more partitions, Azure support will gladly have you pay more. And the number of partitions, again, are set at creation, and you're pretty much locked into that decision. You can always, of course, recreate another Event Hub and just change configuration point over to that other one, but it's kind of a pain that gets locked in. Partitions, really what they do is they represent the amount of parallelism you're going to support in your consumers. Generally speaking, you want to go with a higher number of partitions. Unless you have a reason not to go with 32, I say just go with 32, just because you don't necessarily know what you're going to need to scale to. The exception to that is if there's some resource that your consumers depend on that doesn't support concurrency or doesn't support a lot of parallelism, you're going to end up with a lot of contention within your consumers, and then it might actually be in your interest to go with a lower partition count. For example, if you are doing a lot of SQL database writes, we know that relational databases, there's a lot of locking that goes on in there. So potentially you're better off with a lower partition count. And then finally, consumer groups. Consumer groups are basically a view into the Event Hub. You can have multiple consumer groups, actually up to 20. And that actually, it does look like it's a hard limit, interestingly. But that's a lot. You probably won't have more than 20 partition groups. And the way they work as a view into the Event Hub is that the consumers within a consumer group keep track of how far they are into the Event Hub, and each consumer group has their own, their own state for how far they are in the Event Hub. They are completely independent. They each have their own connection string to connect to it. The maximum number of consumers is the number of partitions. Remember, partitions is the amount of parallelism you support. So if you have 32 partitions, you can have per consumer group up to 32 consumers. So to put that in kind of concrete Azure terms, consumer group is like your cloud service worker role. And then the consumers within that consumer group is just how many instances of that you have up. All right, so that was just a lot of text and words and maybe didn't make sense. Let's see if we can portray that into pictures. So here I have an Event Hub with 2 partitions. Processing against those 2 partitions are 2 consumer groups, A and B, that both are running 2 instances. We'll just start talking about consumer group A. It pulls, each of their consumers pulls a batch of events off the Event Hub, and they process them. Whatever it means for that particular consumer group to process them, it finishes that work, and then it does what's called a checkpoint. The checkpoint is basically your way of telling Event Hubs, I got this far in the Event Hub, so that way it knows where to pick up where it left off. Then consumer group B, actually concurrently, it's not then, it's concurrently, consumer group B is also pulling events off the Event Hub. It processes its batch, and then it issues its own checkpoint for how far it got in the Event Hub. Consumer group A goes again. This time, for whatever reason, the first consumer didn't pick anything up. Doesn't matter. The second consumer, they work independently. It can continue processing. That consumer finishes its work, checkpoint. Consumer group B picks up the next batch of work, and again advances its checkpoint. It's important to note that all that, I kind of explained it one after the other, but it's pretty much happening concurrently. Consumer groups do not coordinate with each other at all. They have completely independent access. They don't block each other in any way to the Event Hubs. Within a consumer group, the consumers have reserved access to their partition. So there's never contention, even within a consumer group, for the same partition resource. That gives you the partition consumer model, reduces the locking, and gives you high throughput. So let's take a look at some code and see what it takes to build one of these applications. So we'll start talking about the publisher. And I was just having fun with this. The application is the karma tracker. So it just keeps track of the activities that the actions people take, associates some kind of karma point value to those actions, and sends it into the Event Hub. Positive numbers means you're doing good things and you're going to be rewarded. Negative numbers, you're being bad, you're going to be punished. So looking at the publisher, we start, can everyone see that okay in the back? Is that okay? So we start by getting some configuration. We need a connection string into the service bus. We need to know what the Event Hub name is. But the important bit here is the Event Hub client. As the publisher, that's your interface to the Event Hub. That's what you use to write events into it. That Event Hub client gets passed into this event writer, which is a custom class I wrote. I'll show that in a second. And then I provision a set of people that I'm going to be tracking. This is Stir Trek Ultron Edition, so I have some Avengers characters in here. And for each of those characters, I'm going to create karma events. I'm going to serialize that into an event data and Event Hub event data. And the message body for Event Hubs is either a byte array or a stream. So any kind of serialization, you have to take care of all that. In this case, I'm serializing it to JSON, and then UTF-8 encoding it into a byte array. The event data also has a properties dictionary, which you can kind of think of as like your HTTP request headers. They're just key value pairs of metadata, processing instructions, whatever makes sense for your system. And for each of those event datas in that loop, I just write it to my event writer. The event writer, again, that's a class I wrote. As you recall, I said that if you are sending events at a fast, high velocity, you really want to batch the messages if you can. So what this does is just take events and keeps track of a write buffer. And when that write buffer, the capacity of that write buffer exceeds the maximum amount of bytes for a message, then I flush those events to the event hub and then start the new buffer. So it just kind of simplifies the batching logic. Not really a requirement, but very helpful. So if I go back here, you see the amount of code is trivial, right? Create my Event Hub client for my connection string, and I can just start writing to it, sending messages. The consumer is equally simple. So I have my configuration settings up here, and I create an event processor host. The event processor host comes from a NuGet package, a separate NuGet package that is provided by Microsoft. Absolutely recommended you look at using that if you're building a Event Hub consumer, because it makes processing events pretty trivial. All you do is define some options. In this case, I'm telling the processor to prefetch, or basically cache or queue up, 10,000 messages to be ready for processing. And I'm telling it I want to process those events 10,000 at a time. With Event Hubs, you really do want to process in batch. And then I register my Karma event processor. And that's it. It starts just processing. But let's look at what that processor does. Any processor implements this iEvent processor interface, which has a very simple contract of 3 methods: close async and open async. So that's my setup and teardown that I need for my processor. And the important one is this process events async. That method is called for every batch of events that I want to process. And that batch goes into this messages enumerable. So in this particular instance, I'm just looping through all those events. I'm accumulating how much karma you've earned or unearned. And then I'm just throwing it in a dictionary because I only have one consumer in this case. Obviously, you would want to persist it in some kind of, data source, some kind of data store. And then, importantly, after I'm done processing that batch, I need to issue my checkpoint. I need to tell Event Hubs, okay, I'm done with that batch, I got to here. You do have the option to checkpoint at specific positions in the Event Hub. You don't have to checkpoint like the entire batch all at once, but that certainly would be the more common use case. And that's it. I mean, obviously, your code in here would likely be much more complex than this, but there's really not a lot of plumbing you have to do. So up to now, the talk has kind of been pretty dry, just bombarding you with information. So I thought maybe we'd have a little bit of fun and try and guess what the karma tracker said about these characters. So just yell out, good or bad, what you think the fortune is for Mr. Ultron here. Wake up. Bad. Yeah, Of course, he's the bad guy. He's the villain. Sorry if I spoiled anything for the movie, but he's going to end up in the trash heap. What about Captain America? Good, bad? Good, of course. Captain America, he's going to win the lottery. What about Iron Man? Mostly good, good. Meh. You know, he's a good guy. He's a superhero. He saves the day. But everybody he meets, he's a dick to. So karma doesn't really take a liking to that. What about the Hulk? Smash? Good. Well, of course, good. He's a superhero. He saves the day. But wait a second. He just destroyed the entire city. Karma doesn't like that. So, you know, karma makes him stub his toe. He gets pissed off and burns down his fortune. What about Thor? Good. Doesn't apply to Thor. He's a god. He wrote the rules of karma. He's got an exemption. All right, enough fun. Back to business. So I mentioned the event processing host. It's very configurable, so you can set it up to handle whatever your workload happens to look like. I didn't show it in my example, but it does support dependency injection. Instead of registering an event processor, like the concrete class, I can register an event processor factory, and then my implementation of that factory can use whatever IOC container or dependency injection framework I want to use. And it takes care of all the batching, the checkpoints, the partition leasing. And partition leasing is a pretty critical part of Event Hubs. When within a consumer group, every consumer has reserved access to a partition. That's what prevents us from having to worry about contention and coordinating with the other consumers. And that's done through leasing. So each consumer within a consumer group basically says, I own this blob. And that leasing period is configurable. It's usually a very short span of time, so that if I don't renew the lease, another consumer will very quickly pick up that lease and pick up that partition and continue processing. Through that partition leasing, we get dynamic scaling and consumer balancing. So in this image, I have an event hub with 8 partitions. All 8 partitions are being processed by one consumer within my consumer group. But then that consumer starts getting overwhelmed, right? There's too much volume of data going through that event hub, so we need to scale it up. We add another instance for that consumer group, and over time, and again, if your lease period is very short, it won't take long at all. The balance of those partitions will be shared evenly across those consumers. And we can continue to add consumers, to satisfy demand. And if consumers go offline, those leases will quickly expire, and then other consumers will pick up those leases, those partitions. So let's revisit that smart grid, smart meter use case from earlier. And again, this is completely fictional, has nothing to do with that IoT application I built a year ago. But in this fictional use case, we have 3 high-level functional requirements. First, we need to know how much power a particular home used, so we know how much to charge them for that power, so billing. And we want our smart grid to be adaptable to the demands of the market. So if this neighborhood over here starts consuming more power, I'm going to increase power generation and direct all that power to that area and leave the other areas alone so I can be more efficient. This is big business right now, trying to figure all this stuff out. The third one is I just want to know if the meters are behaving correctly. Right, the meters will start giving me error codes, and I want to be able to know when and where I need to send a technician. In addition to those functional requirements, we have some throughput requirements. So, in this imaginary use case, this is a ultra mega huge utility company. It manages 50 million homes. That'd be over a third of the U.S. market. And each meter sends a message every 5 minutes. So huge amounts of meters sending messages every 5 minutes. Comes out to 167,000 messages per second. That's a lot of data. We were smart though. We, from that prior set of slides, we're using the binary format. And it's 20 bytes per message. So, let's put our thinking caps on and think about how we would build a system to satisfy these requirements. But I'm going to make it harder for you, and I'm going to ask you to imagine this is 5 to 10 years ago, right? Cloud existed, but maybe it wasn't taken as seriously as it is today. So this was probably like an on-premise application. 5 to 10 years ago, there was a lot of client-server. I mean, that was pretty much the default mode. So imagine building a client-server application where we receive the event and then real-time have to process it right there. Oh, and by the way, we have to do all those different operations on it. Now you may say, well, I mean, we had enterprise service bus technologies 5, 10 years ago. Sure, that's a step in the right direction. But then we're back to we end up with a complex architecture where we have events coming into one queue, and then maybe it gets multicast into these other queues, and then after this queue is done processing, the event goes into another queue. Chances are we have more functional requirements that get added after these first 3 are solved. So you end up with a really complex, either complex code or just a complex architecture, a lot of moving parts. So fast forward to Event Hubs. We satisfy all the functional requirements by creating a very focused and specialized consumer group for each of those functional requirements. So we have a consumer group that its job is just to aggregate billing. We have one for adjusting to the usage patterns and one for the detecting the meter failures. But they all process against the same architecture. So there's no increased complexity. And they don't compete against each other in terms of throughput. Now, to support that volume, like the non-functional requirements, we actually only need, for that use case, 6 event hubs to handle all that volume. And it would be 3 event hubs if not for the fact that we have a 3-to-1 ratio of consumer groups well, we have 3 consumer groups. If you remember, a throughput unit, it has a 2-to-1 ratio of read to write. So because we have more than 2 consumer groups, we need to up the throughput units a little bit. But that costs $132. A big system like that, handling 50 million smart meters, I'm spending $132 for those event hubs. Now, there's additional costs. You pay for the transactions and all that kind of stuff, but you'd be paying for that anyway. And of course, you have probably big compute resources to process all those events. But I think it's pretty remarkable that we can satisfy that kind of throughput at $132 a month. Pretty amazing to me. I'm not sure why I made a separate animation just for that. So 50,000 messages per second per throughput unit. So tips and tricks. First, you don't want to reinvent the wheel, right? Don't do what those 2 guys are doing and avoid the very helpful tool, which is the event processing host. You are free, if you'd like to, figure out how you're going to handle your own batching and your own checkpointing and your own leasing and balancing the partitions. You can try to solve that on your own if you'd like. I would not. Take advantage of that event processing host. Secondly, well, actually, let's explain the picture. If you've ever been to Japan, the Japanese understand that to get the volume of people through the subway, you need to pack those subway cars as much as possible. So they actually have guys who their job, they're just guys with white gloves in official uniform, and their job is to just push people into the subway cars as much as they possibly can. And the amazing thing about that is nobody gets upset. Nobody gets upset about being shoved in like sardines into a subway car. But they understand batching is helpful for handling throughput. So batch as aggressively as you can. And it's one thing to batch inputs and outputs into the Event Hub, right? But you also need to think about batching your workload in the event processor itself. What do I mean by that? So if I define my event processor host to have a batch size of 1,000 events, and I get 1,000 events in, but then in my processing method, I for each over those events, and for every event, I read from the database, and then I save some data to the database, and then the next event, I read some data, and then write some data. I'm completely killing the point of that batching, right? Because I'm making so many round trips. So when you take your 1,000 messages, think about how to read all the necessary data, process those 1,000 messages in one, all at once. And then do your computations on that data, and then save the data for all 1,000 events all at once, and then do your checkpoint, move on to the next batch. That's really critical to achieve high throughput. Debugging. Event Hub applications are very challenging to debug because generally speaking, when I'm starting my debugger against, for an application targeting Event Hubs, chances are I'm the only consumer, and let's say I have 32 partitions on that Event Hub. So my processor, my consumer, creates 32 threads to process all 32 partitions, and then I'm processing in batch like a good citizen, so 1,000 events at a time, and I'm doing some good asynchronous programming, so I'm creating 1,000 threads for every partition. I mean, you just get so lost with context switching through the threads. So, when you need to debug locally, set your set your batch size to 1, and then in the processing method, the very first statement was just an if statement. If the partition ID doesn't equal 1 or whatever number I want, just return. So then you're processing one consumer, batch size of 1 at a time, so that you're not constantly switching around. I found that very helpful. Multiple consumer groups. This is kind of an important big deal, I think, when designing your Event Hub system. And it took me a long time to think of a good analogy to use for this. I was racking my brain, and then of course it hit me, the brain. The way your brain is structured, it's got different compartments that are responsible for different functions. But each of those, each compartment of your brain takes the same input. They all take your sensory inputs. But they do totally different things with those inputs. And we want to design our Event Hub applications the same way. The Event Hub itself gives us our input. They all have the same event data coming in, but the way we work with that data is very different. And we want to separate that as much as possible. Consumer groups are a great way to do that. And I think more and more those kinds of disconnected systems and really componentized architectures are, they're making a big impact in our industry, and they're going to do so even more. So finally, let's talk about some complementary services. Pretty much everything in Azure or any cloud provider, they tend to work well together, all the services, and these in particular with Event Hubs. So Stream Analytics gives you the capability to write what looks like SQL against an Event Hub. So you can do real-time querying and real-time analytics against the data as it's coming in. Machine learning, I can see a lot of potential with Event Hubs there. we can imagine two consumer groups. One consumer group that takes data in from the Event Hub and feeds that data into a machine learning algorithm to basically train that algorithm and make it smarter. At the same time, we have another consumer group that pulls events off that same Event Hub and basically queries the machine learning algorithm to make predictions. So you have your machine learning algorithm getting smarter and making predictions at the same time against the same stream of data. Could be pretty exciting system like that. HD Insight is very similar to Stream Analytics, except HD Insight, for those who don't know, that's Hadoop. So you're doing big analytics, big data, where Stream Analytics gives you kind of real-time insights into the data as it's kind of coming in live based on, you're limited to the amount of retention period you elected your Event Hub to have. Whereas HD Insight, as long as you have a consumer group who its whole job is to write data to Hadoop, you can now harness all of that data over whatever span of time, big, giant computations. And then table storage, document DB, and really that list could go on to any data store that supports a high amount of concurrency and a lot of throughput. What would not belong in that list is a relational database like SQL database. In order to achieve very high throughputs, you need parallelism, you need distributed databases, and you definitely do not need locking and contention within your consumers. So with that, are there any questions? Yeah.
How would the message queuing work with like notification services? So you could do message queues to then spin off to like Apple or Google messaging or push notifications?
So the question was, how would Event Hubs work with notification services or notification hubs?
Would you end up having the notification, I guess, subscriber then pulling off and having to somehow flag messages already being sent, or would you end up with like duplicate push notifications?
So honestly, I don't know a lot about notification services, notification hubs. So I actually can't say that I fully understand the question. But yeah, I mean, it'll be something like you'll have so essentially what's receiving messages from the notification service would be your publisher, I would think, and it would author events into the Event Hub for downstream processing. As far as handling duplicates, I think you would just have to be on your own on that one. Yes?
If you set your processing host to do 1,000 message batches, does it wait until you hit 1,000 messages before it will submit that batch to the processing host?
So the question was, if I configure the event processor host to have a batch of 1,000 messages, do I have to wait until I get 1,000 to process? And the answer is no. It will. You can also configure a time interval. So up to 1,000, or if this time span hits, then process. Kind of interestingly, though, about that event processing host, you can say, I want batches of 1,000, and even if you have 1,000,000 events in the Event Hub, it'll give you 50, and then it'll give you 120, and then it'll give you 800, and then it'll give you 300, and then it'll give you 45. It decides all on its own how big it actually gives you the events. I don't know what it uses, what kind of algorithm it uses to optimize that, but it's really a hint for how big you want your batch to be. Yes?
What goes into deciding the retention period? Are there limits you have to push up against, or what's a typical retention period?
Yeah, good question. Azure, so each throughput unit gives you 1 day of free storage it gives you 1 day of free storage. If you think your workload might take longer than a day to work through all that data, you might extend it. Also, if you're doing stream analytics and you want to, like, let's say you want to have real-time querying over 5 days worth of data, then you would set your retention period to 5 days. But pretty much set it as short as you can to where you don't need it anymore. So if you're reasonably sure you can finish all the processing within a day, set it to a day, no additional costs. About the additional costs, if you set it to like 5 days retention period, but you don't fill up the blob, like you don't really have a lot of volume, there won't really be additional costs. It's just you get 1 free day at full capacity. So, good question. Oh, did I see a hand there? Or? No. All right. Well, I think that. Well, let's get through the resources. So, I would definitely recommend going to the Azure main page and clicking on the Event Hubs page. Microsoft, I think, especially in the past year, has done really a wonderful job with documentation of their services. There are tutorials and guides. They talk about use cases, give you some really good, pretty robust code samples to play with. So definitely take a look at that. And if you don't have an Azure subscription already, get your free trial, and nothing beats just plunging into it and playing with it. It's, as you should have seen in my code sample, it's really simple to get started. So thanks a lot for your time.